This is an electromagnetic relay. Its control principle is very simple. When we connect the coil to electricity, the coil will have magnetism, and its armature will be attracted. Then the small light bulb will be lit. This is its circuit symbol. Then build a peripheral circuit for it. When we close the switch, the small light bulb will be lit. You can take a look at the shell of the relay, which says coil 5 volts. This parameter means that when we apply a 5-volt voltage to it, the relay's contacts will close. What will happen if we apply 1 volt or 10 volts? If it's 1 volt, the electromagnetic force generated cannot attract the contacts. But if it's 10 volts, the coil of the relay may be directly burned out. Generally, a single-chip microcomputer controls the relay. Without our manual operation, when we give this MOSFET a high level, it will conduct. The coil of the relay is energized, and the small light bulb will be lit. This MOSFET can also control the on-off of the light bulb, so why don't we directly use the MOSFET to control the small light bulb? Isn't it superfluous to add this relay? In many cases, MOSFETs can also replace relays. However, relays can easily handle high voltages and high current. Take this relay as an example. You can see the parameters on its shell. 110 volts DC means that under DC voltage, it can withstand a maximum of 110 volts. 380 volts AC means that when AC is applied, it can withstand a maximum voltage of 380 volts. For example, if we connect it to a 220 volt AC, it can easily handle it, but MOSFETs cannot be applied with AC. Also, the relay has electrical isolation function. Its coil terminal and load terminal are completely isolated. Even if the load is short-circuited, it will not endanger the circuit of the coil. Next, let's talk about the disadvantages of relays. This is the data manual of the relay. You can take a look. Its mechanical life is only 100,000 times. That is, when the relay is loaded. When the number of switching reaches 100,000, the relay may not operate reliably. Using MOSFETs, we don't need to consider the number of switching times. Let's look at its action time, is about 10 milliseconds. It can be switched 100 times per second, but generally, the relay to be switched on and off so frequently, which can easily cause damage to the relay. Let's look at the MOSFET. Its conducting time can reach 10 nanoseconds. In the time it takes for the relay to close once, the MOSFET can be switched 1 million times. There is also heat dissipation. Relays generally do not need to be cooled, but for a slightly more powerful MOSFET, need to be equipped with heat sinks or fans. This is some differences between relays and MOSFETs. I hope it's helpful to you.